Hello again, and welcome to 5-Minute Physics. Today we're talking about electric field lines regarding particles and how to draw them. Okay? Quick note on electric fields. You have positive particles and negative particles. That should be self-explanatory. Okay? So this is going to have a charge of positive Q. This is going to have a charge of negative Q. Okay? Now the way this works is that charge lines, or field lines rather, always move from the positive to the negative. So from positive particles, you always have the field lines going out like this. Out from the positive, out from the positive, out into nothingness towards whatever they happen to be going towards, and towards the negative. So from wherever to the negative particle, like so. Okay? Now what happens when you have two particles in proximity like this, or even long distance, it's just harder to see, is you get magnetic field lines, just like we just talked about, from the positive to the negative. So you'd get from the positive here, there we go, from the positive, from the positive to the negative, and arcing out a little bit from the positive to the negative. Same thing on top, and all the way around. And you get these nice, not concentric, but these nice layers, I suppose. Oh, that's a mess up. Here we go. That's better. And then you get the ones that go out into seemingly nothingness, that they actually just go out towards other particles. We may not be able to see them, but that's how that is. And again, to somewhere, from somewhere. So towards the negative charges, out from the ether, towards the negative particle. And that's what it looks like when you have a positive and a negative particle together. Alright, now suppose one had a bigger charge than the other. What would happen then? Alright, well, let's say that, there we go, if one of your charges was larger than the other. So if this was not Q, right there we go. If this was not Q, but 2Q, what would happen then? So this would be plus 2Q instead of the minus Q that we've got over here. What that means is that this is twice as strong as that one, so it's going to have twice as much energy coming out of it. So let's have a look at that. It's almost like nothing. Okay. So back to yellow. There we go. We're still going to have the charge lines going from one to the other. But this time they're going to be a lot more forceful, meaning there's going to be more field lines from the 2Q. So instead of just your typical couple like that, it would be a little thicker like this. And I know that's not particularly accurate, but there are more field lines. So you still have from the positive to the negative. And they might overshoot a little bit because the positive is stronger. There's more force coming out of it. So you might get a bit of a kind of a pear shape almost like this, with these extra lines flying out into somewhere. And coming back here. So that's what it would look like. A little bit different, but this one is stronger. Alright. Now, what would happen if you have two positive particles next to each other? Well, it would look something like this. What did I do? There we go. Alright. So we've got two positive particles. They interact with each other similarly, but not the same way as a positive and a negative would. So again, you've got Q and Q, except that they're both positive this time. So positive Q and positive Q. And to draw the field lines, you normally have from the positive to the negative, right? Well, in this case, since they're both positive, they might go and then decide they're not going to go there, because the same poles, they're not magnetic, but the same charge repels. So you get this kind of thing going on in the middle here, where you still have the charge lines, but they deflect each other as you get closer between the particles. So it looks something like this. Charges of the same sign don't get along. They repel each other. So there you go. And the same thing applies when you have two negatives. You'll have, instead of charges from one to the other like this, coming from the positive, you'd have going to, but they also repel each other. So it'd be the same thing, but in the opposite direction. That's an arrow. And I think you get the basic idea. Okay? Well, that's about it for magnetic field lines. Thanks for watching, and see you next time.